In this lesson, we're going to learn about the maximum and minimum values of a graph. So if we had something like a cubic graph, for a cubic graph x cubed, you're going to have a maximum point and a minimum point. And that maximum point, the absolute highest point or the absolute lowest point of the cubic graph, is called the absolute max or absolute minimum point. If it was an x to the fourth graph or x to the fifth graph, then you can have relative max and min points, or sometimes called local max and min points, because there's more than one hump and valley or peak in the graph. If you take a look at this graph here, we're going to identify points A to E on this graph. So you can see from this has two humps and one valley, so it's probably an x to the fourth graph, because we'll assume that it doesn't continue with humps and valleys. So point A is an endpoint at -2. So the x value is at -2, the y value is at 1. Point B would be considered an absolute max, with the x value at 0, the y value at 3. C is a relative minimum value. The x value is 1, the y value is -1. D is considered a relative max at 2, 2. And E, since it's below the point C, that's why E, since it has an open circle, it's not considered in the domain of f of x. So since the graph continues further down past C, that's why we refer to C as a relative or local minimum, not an absolute. And so here's a listing of the answers. Again, A is an endpoint, and we list the ordered pair -2, 1. B would be the absolute maximum point. C is the relative minimum point. D is a relative maximum point, and E is not in the domain. So to determine the max and min values, without a graph, you need the endpoints of the domain and the critical points of f of x. The critical points are found by finding the derivative and making it equal to 0. So to find the absolute maximum value and the absolute minimum value of this cubic equation, with the endpoints -3 to 3, so we're only looking in that range of the x values, the domain from -3 to 3. First thing we're going to do is take the derivative of y. So taking the derivative, y prime becomes 6x squared plus 6x minus 12. And in order to find the critical values, which are the zeros of the graph, we're going to factor 6x squared plus 6x minus 12. And we notice that 6x squared plus 6x minus 12 has a GCF of 6. So I'm going to factor out the 6, and then I'll factor x squared plus x minus 2. So I'm going to place these critical numbers or zeros on a graph, still using my domain endpoints -3 and 3. So we check the critical numbers into the original. If you were finding out where the graph was increasing and decreasing, that's the slope. So if you're plugging it into the derivative, you're finding out the slope of the line. We're not looking for that here. We're looking for the maximum and minimum points of this curve So we have to plug these endpoints into the original equation. So we need to keep that clear. If you're finding max and min, the critical numbers go into the original equation. If you're finding out whether your graph is increasing or decreasing, then you're going to plug these critical numbers into the derivative, the first derivative. So I notice if I plug in x equals -3 into the original equation, my y value is 10. If I plug in -2, my y value is 21. If I plug in my x value of 1, my y value is -6. And if I plug in 3, my y value is 46. So my absolute maximum point is at 346, 3, 46, the ordered pair, and my minimum point is at 1, -6.